can't see it. Here's my little guitar. Welcome to the Ben and Ryan Show, episode 5.
Amazing.
Today, I know. For our mothers who've watched our shows every week, and you've seen the progress we've made, and we kind of build upon it every week. Last week, if you watched the show, we had the pom-pom hair. It's not here anymore. But this week, so I rated my daughter's little Barbie set, and I got a guitar so I could rock out in the beginning. So anyway, welcome to Ben and Ryan Show. I'm sure you're hooked by now. In the first 45 seconds, we've told you everything we're going to talk about today. But so I've broken all the rules of YouTube. So today we have a special treat. We're going to kind of do a continuation of a couple of our podcasts where Ben and I have talked about cloud hosting and kind of what's going on in that world. So today, as the kids call it, we are going to double click into cloud hosting. So I'm going to get into that. And we brought on Dakota Clum. He's CTO of xByte Cloud. And he's going to be talking to us today, answering our questions, a lot of Ben's questions about cloud hosting. And I'm going to throw one out there because I recalled it from one of our previous podcasts, Ben. You were asking me, how do our customers kind of deploy development code?
Right.
Are they using special environments? Are they doing FTP? Are they just editing stuff on the server? What does that look like in modern day, and kind of what do we see in our customers?
Right, because I think oftentimes what happens in the technology world is we live in our own little private worlds where we have our tech Twitters or our blue skies or our mastodons, and we have a group of people that we communicate with, and we're sharing ideas and we're reacting to other people's ideas, and we get the sense that this is just how the world works, and this is the information and the idea exchange, and everybody must do things this way. And then you go to a conference or you get into a conversation in an unusual place and you realize, oh, the whole world doesn't actually operate like this. I've been working at a company where we've been doing containerization with Docker and Kubernetes and CI/CD and deploying images and horizontal scaling. And so it's very easy when you're doing that for a couple of years to think this is the way, quote unquote, the way, and this is how everyone's doing it. But then when you look at something like managed hosting and VPSs, it's you forget that not everyone is operating under the same constraints. Not everyone has the same needs. And I think it would be very informative to get some insight into how other people accomplish the same type of work.
Yeah, that's a great overview. And Ryan, thanks for having me on. And Ben, look forward to diving into this conversation with you. So I think, as you had mentioned already, with CI/CD, it is still a popular way, or I'd say even probably one of the most popular ways to deploy applications into a production environment. As we look into more of a managed hosting ecosystem, or what we'll refer to as traditional virtual machine or VPS, there's still instances today where end users will establish an FTP connection to the server. They'll make their file changes independently one by one, and kind of test the changes in real time live. Sometimes that's done in a dev server capacity. They'll stage it at a dev server, move it over to production. But we definitely still see instances where FTP access is very prevalent, just to go in, push changes, be able to access the file system in real time, and push, I guess what you could call a rapid deployment, to a server and hope it works. We do have clients that, take a more modernized approach to where everything is, controlled by source. They have a staging environment, or they have a dev, a staging, and a production environment, and they're actually pushing their commits or their merges directly into production or directly into staging, using an agent on the server. So you could leverage, Jenkins, for example, and connect that to your repository, push down any changes. Another common one is Azure DevOps. We've seen that a lot. GitLab, of course, you have GitHub as well. So that's prevalent as well. For customers that don't use FTP or more traditional CI/CD implementation, we've even come across scenarios where they will RDP into the server directly or access the server environment directly and make a change in a file editor directly on the server. And that works in some scenarios. In other scenarios, it doesn't. Typically where we've always pushed our clients is, you want to make any changes regardless, really how you're pushing them in a dev context where you can change your, change your files and understand the impact before introducing them in production. And for some, that's okay. And for others, they have a process and it's worked. So.
Right. So if I can just jump in for a second, because I want to be clear with the listeners here that I don't think any of this is a judgment on how people do stuff. I do think that we can safely all agree that source control is a thing you just have to do. I mean, to do anything without source control seems bonkers, and it shouldn't even affect the way you deploy. So it doesn't have to really even be part of this conversation. It should just be assumed. But the reality is, as Dakota was saying, there's things that are just necessary for the way you do things, and there are things that are not necessary for the way you do things. And everything is a trade-off, right? You talked about FTP as a quote unquote rapid deployment. I was listening to an interview with one of the guys at Shopify, and like every single deployment at Shopify, I hope I'm not misremembering here, goes through a minimum of a 75-minute build and CI/CD process. And it's like they have, hundreds of thousands of tests that are running. And this is the optimized, like they've done as much parallelization as they can. And I think it runs across like 45 different test servers concurrently. Something crazy, right? But they're also powering like an estimated 10 to 20% of all commerce in the United States, then that's fine. That's the process they have to have in place to ensure quality. If every typo fix that I made required a 75-minute build process, forget about it. That'd be so wildly inappropriate and disproportionate with my requirements. So all of it is a set of trade-offs. What you're losing in some sort of modern technique, you're probably gaining in an efficiency, a speed of reactivity. There's no one right answer here. And I just want to always reframe the conversation that way.
Yeah, and I think I've been in environments where I'm just like, hey guys, just make the change on the server. It's okay. You copy it back to the source control, but we need it down. We need that change now. We can't wait for whatever other things need to happen. It needs to be updated right now. And so it all depends on what you're doing. If it's a blog, then who cares? It's like, okay, yeah, I can update a file. And if I'm changing the CSS code or something, okay, the look and feel of it. Okay, if something happens with that and it's not the correct shade of purple or something, then we're all going to live. It's okay. It's not Shopify.
And I think
I had a question. Oh, go ahead.
I just think it's also important to remind people that they can evolve into an appropriate solution. That the thing that works for you on day one isn't necessarily the thing that has to work for you on day, 365. That your complexity can evolve in parallel with your solution space. I remember when we were early in the company and before we had learned about containerization, me and one of the other engineers would literally remote into servers and start pulling servers out of our F5 load balancer and then waiting for traffic to drain so that we could run Cold Fusion updates and then plug those servers back into the load balancer. And you go back into the dashboard and you say, this can start receiving traffic again. And it was awful, but it was awful once or twice a year. And for the rest of the year, it was a git pull to a particular server. We had a couple of servers running in parallel. And Dakota, man, maybe this is something you can talk to as well. One of the things that we would have to do in order to do load balancing in a situation where we didn't have containerization is we had essentially a master server, and we would remote into that, do a git pull, and then I think it was called rsync would essentially monitor that and say any file changes made within this directory, we're going to immediately sync to every other replica server. So we were essentially load balanced, but we're only deploying to a single server. And you know what? it was awful in ways, but it was also super fast. It was, how fast could you remote in and do a git pull was essentially how long it took to deploy code.
Right. Yeah, it's funny you bring that up. That's a very similar environment, we still see today, where there's a master server, you push down any code changes, and that gets propagated to any other servers, as a part of the load balancer. And then even to your earlier comment about draining a server from a load balancer, being able to push an update or push a change, that's still something we see commonly today. And then even for those same organizations, we're seeing more of I'll use the word rapid again, like a rapid transition into more of a CI/CD driven protocol. So it has been nice to see how, over the years, this, what we'll call a deployment strategy has shifted, or, being able to deploy to code. And it's been fun to see it, all the way from the server level and then all the way to a CI/CD driven application.
So Dakota, two questions on this. One of which is all on the multiple servers front. For our customers who are doing load balancing, are they doing what we just described, where you kind of put it onto a master server and it replicates, or how are they set up?
Yeah, it's a great question. There's a few options. To Ben's earlier point, that is a scenario that we support for some of our clients. You could take that a step further and implement a very highly performant read-write NAS solution, where your file system is shared across multiple servers. And of course, that's backed by RAID. It's highly available, fault tolerant, where that can be, rather than syncing, all of the operating systems are actually sharing the same shared storage in the back end. But it's still propagating across multiple server environments or servlet and serving.
And that's in the cloud, we're doing that?
Yes. Yeah.
Man, I learn new stuff every day. This is awesome.
So yeah, there's and there's trade-offs to that too, right? So there's I think what's really important is just understanding your architecture, your application, and what you believe it can support, in terms of deployment, or what you're most comfortable with, depending on your risk appetite. There's a lot of scenarios that can be implemented.
Risk appetite is a great phrase. Absolutely.
Yeah. And then it's the SQL. If people are doing load balancing on SQL or Microsoft SQL, they handle that, correct? So they actually have with their.
Well, there's a few ways to look at SQL. You do have this, the built-in SQL replication. Of course, there's licensing implications there. You have always on, like, highly available groups. You can, it supports clustering. So it can handle all that back and forth synchronization for you. You could also take like an active passive approach, where even in a load balancing context, we can turn that into more of a geo-failover or failover context and say, okay, well, I have, my primary server A and my SQL server B. And then over here in another region, I have, the same exact setup, but it's in a passive setting. SQL can support that. And then a lot of, most modern, implementations of load balancing or any kind of WAF solution can support that as well.
So you can do a scaled solution even in the VPS world. You don't have to have an AWS or an Azure to kind of handle scale.
Yes. There's such a thing as like the auto scaling groups. Now, is it, can it be considered as effective as a, containerized approach, or even a serverless architecture, which is really just on-demand compute at the edge layer? I think it's still up for debate, and really it just comes back to, I'll use appetite again, Ben, but the appetite of the organization of, what do they want, the robustness, and do they have a team in place to support their application architecture at scale, depending what technologies are in use. So
it's really interesting, the whole auto scaling stuff, because I think it's one of those things where there is this magical concept of the abstraction, but then that isn't always the reality of the situation. And we've even run into that at work, where we've had auto scaling enabled, and we're on Amazon Web Services, And literally we need to scale up, and they just report back an error like, oh, the type of nodes you need don't exist right now. Like we don't have capacity for those type of nodes.
No.
And so what happens is, if you really need a service to be fully available all the time, I think we've often opted into doing reserved instances where you're saying essentially, I want my own server and I'm willing to pay for 3 years in advance or whatever it works out to be. And it ends up being kind of a cost savings because they'll give you a good deal for the reserved instance because they're getting the guaranteed, 3-year contract. But then you're back in this world where we're like, hold on, I thought we were supposed to be serverless. And now in order to get the performance that we need, we have reserved instances for the next 3 years. So it's not always as rosy as I think the marketing materials make it out to be.
And maybe it may depend on some of this. If you can predetermine when your loads may be.
Yeah.
Because you and I talked about this in one of our episodes. If you're advertising for the Super Bowl, you have an idea that, hey, it's going to get busy during the time of year. So go ahead and preload.
I think that I'm pretty sure that was FanDuel or DraftKings was one of those betting sites. And I went to a presentation and they talked about how like a week ahead of time, they like quadruple their capacity. It was some absurd amount of volume that they get ready for, because literally even in a serverless architecture, it can't scale fast enough to at that kickoff, and suddenly thousands of people are refreshing pages looking to see what their stats are like, and what's that imaginary football stuff that people do?
Fantasy football.
Yeah. It's like I don't know. I'm not a sports person.
Well, because we have a customer who, because people talk about, hey, to do scale, you've got to go to AWS or Azure or something like that. But Dakota, do you have the specs off the top of your head? We have a major retailer on our platform using VPS to scale. And I don't know if you directly work with these guys or someone else on the team. We can't give names out. We don't have their authorization for that. But do you know there's the millions of transactions a month? And running on VPS, and not a lot of them. They just have a very performant application that they figured out. Because when I heard the numbers, Dakota, do you off the top of your head? Do you know the numbers?
Yeah,
you know what I'm talking about.
We actually have a few that are kind of in the same boat. But we have a few that serve millions of requests per day, in a traditional what I'll call a VPS architecture, that takes it in stride, without any issues. It really is, when you get to that level of scale, it does become application dependent. Is your code performance, are you addressing bottlenecks or, any slowness? But it is, it is achievable, and we've gotten to see that. So.
And I think one thing that's important to keep in mind is that applications don't typically need to be scaled uniformly. If you think about an application as a black box, and suddenly you're running out of RAM or you're running out of CPU, and you think, oh my God, I have to scale this thing, and now we need to have this really complicated technology strategy. What you might lose in the nuance there is that 99% of your application doesn't really need to scale and is just regular request response web page stuff. And then you have this small little section over here that's doing image thumbnailing. Yeah. And if you just took that part and put it in like I can't remember some of the platforms, like Cloudinary or Cloudflare or ImageX, and now you defer all of the image thumbnailing to them, like now, oh my goodness, you're serving tens of millions of requests an hour because they're just single like about us and career pages and contact forms. And the really heavy lifting that's been pushed off to the side and is now being scaled in a special way. And you can keep your architecture actually quite simple as long as you siphon off just the things that really need special treatment.
Yeah, I think that that resonates really well. I think, something we see commonly is, the separation of services. And it even comes back to, for me, is like the microservices conversation is,
sure.
Can you offload your scheduled tasks? Can you offload your SQL reports that run every day at 9 a.m.? Maybe those can be performed on another server with a replicated, database. So really breaking apart dependencies or what could be bottlenecks and letting them run on their own server, their own resources, we found to be really an effective strategy. Or offloading to the edge or S3 or any kind of CDN type appliance where you can do image caching. That's shown really valuable results as well.
I know from our sister company, xByte Technologies, they send out emails a couple times a week, and we are noticing an overwhelming spike in activity when those email dropped. And it's not from, I mean, we'd love to say it's from the amazing content they write. I shouldn't take that away. but because it happened within like a half second of us sending the email. And what it is all the email protection systems, all the bots crawling your web page right away. And so and we're talking to their teams about, hey, how do we cache certain things to allow the bots to hit that, or how do you set up different protections for bots so they hit different areas, that way that they can still say, yeah, we're okay to go to, but we're not seeing the overwhelming load all of a sudden to our core site, because we have some things that are dynamic where they will load page configuration for a server. So if every possible combination of ways you can configure a server, it's loading it dynamically. And so if we had to kind of work, okay, what's the solution to allow that to happen in different caching worlds? And so it was interesting to kind of work with them on, and a lot of it was working with Cloudflare on images and figuring out, okay, the interesting issue with that came about where we wanted images to be cached for outside people, but Cloudflare allowed us to set up rules that internally they wouldn't be cached, so that if we were doing testing, then we could see the most updated things without having to do special URL tricks to see that. But the outside world would still see the cache versions, and that allowed both teams to kind of test things, because we had a central repository for images. It wasn't like a dev images. It was just because when we found we had dev images, and we sometimes not change the code, and our production would still be pointing to dev images. So we're like, all right, what do we need to do for that? But Dakota, another question. You were talking about the different dev instances for our customers. Do they run those on the same server, or do some people have a separate server in case something happens to their dev environment? What do you typically see?
Yeah, that's a great question. Typically, there will be a production server designated for production workload and stage changes, and then the dev environment is completely separate. It runs on its own SQL instance and its own Cold Fusion or any other framework context. So it's completely independent. We have some clients that maybe they're not doing geo-failover, but they'll say, hey, I want a production instance in one data center, and then a dev instance in another data center, just in case if anything happened to production, I could still stand up on my dev deployment. So that's something we've seen a few times as well.
We talked about, before recording the show, in the little pre-show chit-chat, we talked about the noisy neighbor effect. And that's one of the things that I would think about sometimes when we were back in our VPS days, because we had a quote unquote beta server, but it was literally just a different folder in the same server with its own IIS subdomain. And so essentially our deployment process was we would remote into the server, pull down to the beta server, test that. And then when we were done, I think we had some sort of a beyond compare type of thing where we'd actually just push over into the production folder. Which, depending on what you're doing, again, going back to the idea of risk appetite, totally reasonable. But there is a non-zero chance that you're going to do something in your beta folder that's going to eat up the CPU. And then suddenly it doesn't matter that production and beta are different domains. They're using the same resources. Now you hose your production server as well. But it's all a matter of what you're willing to do and how much things cost. I mean, like a non-zero part of the conversation in my head is increasing complexity is almost always more expensive. And is this something that you want to pay for, and is paying for it worth whatever it is you're getting from it? And so if I have a beta folder on one VPS, that's half the cost of having a beta VPS and a production VPS. And, how much risk remediation is that giving me?
Well, it's kind of going into the DR conversation we also had.
Which conversation?
the disaster recovery conversation we had. I don't know if that was last week, the week before, but we were talking about the same sort of thing. Your risk appetite, as far as how much can you afford downtime, and how likely is that situation. So you kind of can kind of math it to say, okay, hey, I'm willing to, if that 1% chance happens and dev takes down production and it's down for 15 minutes, is that okay? Are those levels of risk okay? And you kind of can back into the app and math it and say, okay, yeah, you know what? Everyone who's going to buy from my site will come back in 15 minutes. They'll be okay. Or like, no, the image loss of being down for 15 minutes is not okay.
Right.
Yeah.
I know I've listened to other people, like technology leaders, talk about some of the tough love conversations that they have to have with the leadership teams, where the leadership team will say, oh, we're only at 4 nines of reliability. We need to get to 5 nines of reliability. And someone has to step in and say, okay, that'll cost another $2 million a year. Like, are you ready? And are you okay spending $2 million a year for another 9? Like, is that really the value you want to squeeze out of our budget? And it's just the reality.
Like 1 minute of downtime versus 60 seconds versus 6 seconds of downtime per year.
Yeah.
Is there value in that? I guess it kind of depends on when that 6 seconds versus a minute is. If it's in the middle of the Super Bowl, then maybe that's an expensive minute of downtime.
We used to have a situation. This is like going way, way, way back. I don't think this is even a thing that's anybody would do anymore. But early on in my career, I was using a Macromedia Dreamweaver. It was the a Visual Studio of yesteryear. And
that was post Notepad.
It was post Notepad, but like pre anything else. And you could set your file system to sync through an FTP site. So if you opened up a file, I think it did something where it would actually deploy a lock file to the production server. Like it would be like about.cfm.lock or something. And then anyone else who was using Dreamweaver to help maintain your site, they would not be able to open that file because there was this remote lock file in place. But you would get into these weird situations where Dreamweaver would crash or something would happen and like the lock file would never disappear. And so you'd essentially be locked out of these files until someone actually went onto the server to physically delete these lock files. And then, now you can get back into that code file. But it just, it worked. It's like, that's the crazy thing, is you always have to come back to it's like, why did people do these batshit crazy things? And you're like, because it got code into production. It wasn't that crazy.
Now, Dakota, we talked, Ben brought up the noisy neighbor that we were talking about again in pre-show, in a dev environment, but we also see that in shared hosting. So if people look at shared hosting and like, it's really inexpensive, but can you talk to people about really what is shared hosting?
Yeah. So shared hosting is, it is what could be considered a cost-effective way to get a site on the internet. But what shared hosting is in reality, and I guess this is where you could ask yourself, if you're operating a website, is typically when you deploy a shared hosting package, you're getting attached to a pre-existing server. So just think of a traditional VPS. And on that server, instead of a single site, there could be 300 or 500 different domains, and every domain could represent a different customer at that hosting provider. And what can happen there is at that point you're sharing disk space, you're sharing compute, network, RAM utilization. If one of those sites have a bad day, or they get attacked, or they decide to fill up all the disk space on the server with log files, that will bring your application down as well. So it kind of goes back to that noisy neighbor effect we talked about, is while you have a site that's out there, you really can't guarantee the same level of reliability as if you were to segment it or have your own dedicated resources. So
in a Cold Fusion world, can each of the websites be its own version? So could you be running, let's say, 2023 update 11, and someone else be running update 7 or something. Is that possible, or do they all have to be on the same update?
Well, it definitely depends. It is possible to deploy multiple versions of CF running independent updates on a single server. There's just some backend changes that have to occur. So yes, it is a possibility. It's not really feasible for, I would say, a lot of companies, because there's a huge management overhead there, especially whenever you do it at the hotfix level. So if you say, I'm going to allow CF 2023 update 10.9.8.7, I mean, that would be a lot of work for the hosting company, but it is possible, yes.
So so generally they would not do that. They would be, and it's inexpensive. It's not worth their time, or it's not worth their money to provide that level of flexibility to shared hosting customers. So they're all going to be on the same version.
On a per update level or per hotfix level, I would say yes. It's probably not worth it. I've seen instances where, you could, especially if you have a lot of domains on a single server, you could stand up a new version and say, okay, hey, we're on CF 2016. It's time to go to 2023. And there's, utility, a capability, within IIS and WS config, you can switch the sites, between contexts relatively easy, which would allow them to switch between versions. So that would be something I could certainly see.
Okay, you still have a noisy neighbor issue there.
Well, and also just for sake of discussion, and maybe this is even relevant anymore in today's world, but noisy neighbor is particularly meaningful when the website is more interactive, when it has a database backend, when it's doing server-side processing. But I mean, I'm old enough that I remember FTPing files to my GeoCities account. And it was just HTML and JavaScript and CSS files. And I'm sure you could get like tens of thousands of domains on a single server, and it wouldn't matter because it's just serving up flat files. There's really no backend load at all. I mean, in today's world, you'd probably just use like a Netlify or Cloudflare pages or like a GitHub pages, or I think even, Amazon S3 can act as a static file web server these days. But depending on what your pages are doing, shared hosting isn't necessarily a quote unquote bad choice. It just, if you're trying to do something powerful, shared hosting is, your mileage may vary.
All risk appetite, right?
There you go. It's the phrase of the day.
Yeah, phrase of the day.
What was the kids show that had this Pee-wee
Herman?
Playhouse?
Yeah.
Like,
we may introduce that now. We may steal that, and every week we're gonna have a special word, and anytime someone says it, we all have to do that. Oh, nice. That's our thing now.
Oh, I love it. All right, so let me ask you a question, Dakota, because looking for some nuance here. When I think about deploying to a VPS, I'm almost always thinking about remoting into the server to get my code there, and that might not be the case. Is there a path where I can have code kind of pushed down to my VPS from a CI/CD system, or am I always pulling? Like, is there a push versus pull conversation to be had when it comes to VPS?
Yeah, so there's a push. There are ways to push. One that comes to mind immediately is just like Azure DevOps. There's an agent that they support that you can deploy on your VM. So you will have to remote in to download that agent.
Yeah.
Agent can be used to facilitate pushes to your actual server and even revoke them. So pull them back. It could be integrated into your CI/CD. So you could do all of your acceptance testing, anything you would do as a normal CI/CD process, and then the last step, actually push that code to a traditional VPS.
So basically, go ahead.
I was going to say some of those actually use FTP to do it, and they're just leveraging that protocol. Some have a proprietary protocol. You may have to expose a port or something on the back end that handles it at the agent layer. So,
gotcha. So just to build a simple mental model here, instead of me remoting into a server and doing a git pull, more or less, I could have a process, basically a background process that is, hand wavy, doing that for me. I mean, there might be a better build process and artifacts getting compiled and prepared and that kind of stuff. But essentially, I can live in a world where my VPS can squint hard enough, be treated like a more modern approach. I'm not having to get into it once it's set up properly.
Definitely. Yep. That is a possibility. It's basically the agent would be performing git pull on your behalf.
Yeah.
But yeah, it could be streamlined totally. Yeah.
Ben, something you brought up in one of the same podcast was in your previous world life, you guys would have to go to each URL or each server URL.
Yeah.
Is that, Dakota? Is that still a thing? I mean, you mentioned Cold Fusion had to be compiled, so you'd have to hit up each load balance server in order to load the CF in that environment. Is that still a thing, Dakota, or are there different approaches now?
Yeah, that's a great question. I think earlier Ben had, mentioned rsync as being one manner of, maybe there's a master server and that, the git pull happens or the agent deploys a code and then syncs it across all the servers. I'm sure there's some kind of native support out there that can, where an agent can support like a multi, context scenario where there's multiple servers to deploy the code to. I'd be surprised if there wasn't. I'm not familiar with one off the top of my head, but that does seem possible.
I mean, you're talking about this Azure DevOps or whatever. I can't remember exactly what you called it. I have to imagine there are solutions like that which will happily pull your code down and then do some sort of like a post-pull script, or I'll hit this URL after I've pulled down the code. And I mean, everybody in the Cold Fusion world, I'm sure at this point, has done something to the effect of, I have a special URL flag that I can put in that'll do like an application stop, or it'll call on application start again, and then kind of refresh all of those in-memory caches. There's got to, so Ryan alluded, this is for Dakota and other people listening here, when we would pull down our code to the master server and then it would replicate over to all the other servers, I literally had a folder of bookmarks in my browser that used F5, the F5 load balancer we're using at the time. You could set a special URL parameter that would be the name of the server, and it would route specifically instead of doing a round robin distribution. And that URL flag to reset the Cold Fusion memory space, I had a different bookmark for every server. So after every deployment, I would just right-click on this bookmarks folder and say open all in new tabs, and it would spider out in my browser to all the different servers. It would reset them all, and we'd be good to go for the most part.
Yeah,
caveats and terrible edge cases there, but yeah.
Yeah. I think that's really the beauty of CI/CD as you really start to take advantage of it, where you can write a scenario as code, or write instructions in your CI/CD pipelines that tell your application, or tell the deployment script, hey, go and hit this URL, make sure it returns as status code, and you can really build off that to make an advanced testing process post code deployment. So I can't imagine what reverting those changes would be like. So you have to pull the code out and then go and hit every URL, kind of manually again and reload it. So, yeah.
But you can, I think, there's a will, there's always a way for this kind of stuff. I mean, I imagine that if you're on this is a Windows specific thing, so I don't know how this translates to other servers, but I assume it's similar. You could have a folder that is your IIS home site for whatever application you're doing, and then you could just create a different folder with a different site, test it, and then just go into IIS and say, okay, this folder used to be the production site, and now I'm switching it over to this folder, and all the traffic starts flowing to the new instance. And if it's all good, then you're good to go. And if it's not, you could just go into IIS and say, okay, start feeding all the traffic back to the previous home directory. Right. And again, like, it sucks that that's manual, and there's probably ways to not do it manually, but it's all a level of effort versus complexity versus cost.
Yeah.
I also
summarize it.
The thing that I always come back to as a developer is what does my Docker Compose file look like? And granted, this already presupposes a certain style of development. But when I'm working in my development environment and I'm going to do Docker Compose up, and it's going to start turning on all the services that are needed for me to do development on a particular application. When you're living in that VPS world, when you're living that VPS lifestyle, I feel like your Docker Compose is looking way simple. You know, it's like here's my MySQL service and here's my CFML service, good to go. You know, you start getting into that serverless world where you're okay. I have my container here, and it's going to push to a queue, and then I have scalable workers pulling off that queue, and they're pushing onto stepped Lambda functions that are passing off to other Lambda functions. Like when I do Docker Compose up locally, you know, what nightmare am I about to step into? And can I even run it all on my computer? Do I have enough resources on my little adorable MacBook Pro to actually get that up and running? So when you're unbounded by constraints, there's an accidental complexity that can very easily creep in. Mm-hmm. Whereas when you're on a VPS and you're very constrained by the kind of life you're living, I feel like you have to be extremely vigilant about not letting that accidental complexity creep in. And that's kind of like that. There's a good aspect to that for sure.
Yeah. I think, one thing I've always appreciated about like a containerization approach is the ability to like rapidly deploy a new environment with, Ryan, to your earlier point about like switching between updates, just being able to rapidly push an update out, see how that works in a server context has been interesting to me. And it creates, it can create a lot of complexities for sure, but it also creates a lot of opportunities, depending on if you have the team or the appetite to leverage the, all the capabilities. But yeah, it's very interesting, for sure. So.
Now, Dakota, we talked a lot about like the development environments out there with hosting, the security. And that's a big topic. And if you could spend a couple minutes going into some of our like real life experiences we've seen with security holes for customers and how we've kind of helped them combat what they've allowed into their environments.
Yeah, I'll happy to talk into that. I'll preface by saying, the security landscape.
Don't give anyone's names out, though.
I'll preface by saying, the security landscape is very large. There's so many considerations, vulnerabilities. It's hard to cover all of them. So really, broadly speaking, one of the things we work closely with our clients on is, making sure you're only leveraging services that are actually a dependency in your environment. We don't want to expose anything to the world. So when I think about ports or, a SQL instance or various frameworks that are in use, what we provide out of the box and what we always aim to provide is just, hey, let's get you a lockdown environment. It's just off the internet. That's how the environment starts. And as we expand and, learn and, kind of understand a client's needs, we can, open port 443 and allow web services. If it's only a database server, that's going to be whitelisted. And, it's not even going to show up on the internet unless it's, a whitelisted port. So we really focus on like what I would call the attack surface to where, we need to understand clients, what their potential attack surfaces are and how we can close those down. From a security perspective, we've seen a lot of deployments where like FTP, we'll go back to that. FTP is wide open. So yes, we know the credentials and we can log in an FTP into our site. Well, a bad actor could be trying to log into the same site and guessing usernames and passwords for months and months. And you may have no idea, but that port's been open. And eventually there could be a breach. Another common thing we see, even in regard from a security context and even regards to scalability, as these VMs or architectures, as you start to see compute rise or sudden bottlenecks in the application, as we've taken a closer look or even dug into environments or logs, we'll find a lot of common like SQL injections, or be a form open that accepts some type of unsanitized query input, where a bad actor is just sitting there trying to scrape your database or pull sensitive information. That's something that's missed a lot. And we've seen that have drastic effects on a customer's security landscape. I think another thing, going back to the attack surface just briefly, is you have to run an environment or operate in an environment that only supports the application's dependencies. So if you're only using Cold Fusion, there should only be Cold Fusion running on the server if possible. So you don't want to have Cold Fusion and PHP and ASP and Node.js all running on one servlet or one container. If for some reason a breach does occur, let's say at the FTP layer or the CF layer, or the even the web server layer, bad actors, they will identify what frameworks are supported on a server, and they will further infect your site to maintain access. So you may get hacked in Cold Fusion, and then a backdoor in PHP, and then a web shell and ASP. That's something very common. And it does go back to even good source control, which we talked a little bit about earlier. Is, as you're uploading or making iterations on your site, you should be able to identify when your source material is changed. And if you're not following those best practices, you're potentially opening yourself up to more vulnerabilities and more vectors for bad actors to get into your application. So I probably only really scratched the surface there.
Let me ask you a question then, because I know about security, but I'm not by any means a security expert. I've heard phrases, but I don't necessarily always know how they apply and in which context they apply. When I hear about cloud computing, your AWSs and your Azures and your Google Cloud Computes of the world, I'll hear phrases like virtual private cloud and virtual private network, your VPCs and your VPNs. And my understanding is in those worlds, I'd have to connect to my VPN in order to do things like remote into a server or run commands against a server on a certain port. Is that specific to cloud computing, or can I have a VPN that only allows me to remote into a VPS or virtual private server?
Yeah, so you can have a VPN that allows you to securely access your infrastructure. There's VPNs. This wouldn't be like your typical VPN you could just go and buy online, let's say.
Right.
But it could be catered to the specific cloud company or hosting provider you're using. And what they would do is segment like a personalized VLAN or virtual network for you that only you have access to, and no one else in the world could even see it. It's not anything that can be eavesdropped on. It's certificate-based authentication, and a lot of providers can support that.
So just to make it extremely concrete, if I had xByte cloud hosting, and I said only people on my VPN can remote into the server or can hit the FTP ports or the SFTP ports, that's possible, but I would have to do it working in conjunction with the tech solution people at xByte.
So yes. Now you could take that a step further. So you could have without a VPN, you could in theory say, hey, I want to be able to access RDP, FTP, and all these various services. But there's still a layer of complexity there because it's done at the server level. You don't really have a VPN type solution.
Right. It'd be like at the firewall, like the web application firewall.
Right. But a VPN, you could really just say, hey, don't allow anything except this. And it's a lot more secure and reliable. But yes, you can do that at xByte Cloud.
And it's not overly complex. I mean, it's a standard offering we have where people can add a VPN.
100%. Just going back to Dakota's point about this is not the general consumer VPN. This is not I'm in London for the weekend and I want to be able to watch Netflix and I can't, so I have to sign into my VPN. That is the same technology, but a different level of buy-in, essentially.
Yeah, that's a perfect example.
I love the idea of the VPN too, because you talk about how something like a database, you would really never want to expose the database to the world, because really your application server is the only thing talking to the database. But the reality is, you're debugging stuff. Engineers want to be able to connect to the database all the time. So you could live in a world where Joe Public could never possibly hit whatever, like, what is MySQL, like 6603? I can't remember off the top of my head. 3306. But you could, if connected to the VPN, hit 3306. And that's super helpful.
Yeah.
The other thing, as far as code goes, I was talking to somebody just a week ago about security, and they were seeing people trying to, this company had a form where they could upload files. And they were I guess they were allowing a certain type of file. So let's say it was a .text file. So they had .txt, but then they had %0, and then the actual like .cfm. So that way it got passed because they saw a .txt on their extension, and the %0, I guess, stopped the parser from checking it anymore. They thought it was just some variables at the end of it. And then it went on there, and Dakota, you and I have talked about this. If the bad actor knows that particular client, the upload client, puts into a certain directory, they then know to go to that directory URL to execute that file. So now all of a sudden they're able to remotely execute code just from a form that allows you to be able to send in your text files or your Excel files or whatever it is. So they get pretty creative as far as being able to do that. So it really takes work to sanitize, to try and think like the bad actor, and not just sanitize for the common solution, but to say, hey, what do we do?
Yeah. I think if you're going to accept any kind of file input, definitely you're going to want to sanitize. Any kind of file upload. Sanitize any input, make sure it's only extensions that you are expecting. And then, don't upload it to a folder like /uploads, so the bad actor can't up to your site /upload /file name, and, try to consider who may be trying to gain access to that. But
yeah, those hackers are so freaking clever. So I don't know if this is what you're referring to, but this is something that happened in the Cold Fusion world. I think when the tiny MCE rich text editor was sort of introduced into the ecosystem, some guy figured out that if he used a load testing tool and hit, like, he knew a file that he was uploading, and the file was being moved the moment it hit the Cold Fusion server. But if he used a load testing tool to, tens of thousands of requests against the server, he could manage to trigger the file before the there's some race condition in the lines of the code where it didn't get moved in time, and he was able to trigger it. But this goes again, it's like, there's the ideal solution, and then there's the solution that works for you. So I'm building this little tool, like an incident triage tool, just mostly for practice. And one of the things I want to do is be able to have people upload screenshots of charts and whatnot as evidence of the triaging. And like, every bone in my body wants to not upload that file to my server. But the reality is like, if I wanted to upload it directly to Amazon S3, or if I wanted to upload it directly to Cloudflare R2, like, it's increasing the complexity, it's increasing the cost. Now I have to deal with like an asynchronous workflow, or like, what happens if the file doesn't exist in the remote file system, or there's network fragility errors. And like, it's ideal, but it's, for an application that probably no one will ever use, is that really the added complexity that I want to start building into my process? Like, even though I know it's the right solution, it's not the right solution for me at this moment for this application.
Right.
And still, like, every day I open up R2 just to be like, well, how does R2 work? and then I'm like, no, close it, go back to building features.
And you can add security later.
Yeah, exactly. I'm trying to do the best practices, like Dakota said, not uploading to a /uploads. Try not to. In Cold Fusion, you can, at least on a Unix server, there's a file set access mode where you can turn off the executability of a file. I don't think that works on a Windows server. I think it uses different stuff. My understanding of server stuff is pretty lightweight, but
yeah. No, that's a perfect point. And, if you are going to upload something, to your exact point is don't allow execution, and then if you do see a file, and I guess that even brings up, the example you just referred to, is if you're staging it in some temp directory first, well, make sure that can't be executed either.
Right.
So if it's to the temp, moves to an uploads. But yeah, it's amazing how they can find a way to achieve, remote code execution, when you think you've covered all the bases. But if you just don't allow it by default, don't allow that execution by default, hopefully it's you're in a safe spot to start. So
let me ask you, this is maybe too technical a question to put you on the spot here. But I know sometimes if I'm worried about people executing Cold Fusion code in a particular file, I will put an application CFC in the directory, and it does nothing but have an abort statement. So any Cold Fusion template that someone tries to hit, in theory, has to go through this application CFC file, and it halts the execution.
Yeah.
If I'm ever worried about locking down a particular directory that maybe could have an ASP.NET file or a PHP or a JSP file on a Windows server, is there like a HT access hack that I could put in that says, like, if I just drop this one file in this one directory, then no matter what file anyone tries to reference from a URL, it'll just be blocked? Is that a thing that exists in Windows?
So yeah, there's a couple tools. One that comes to mind is App Locker, which is native to Windows. You could just not allow any kind of executable. You could specify it by file extension type. And then for Windows and IIS, there's something called a web.config, which is like the equivalent to an HT access. You could, in theory, drop any MIME types that you're not expecting, and make sure that those can't be, when I say MIME types, those are file extensions in general. You could drop all those, or you could take a different approach and only allow ones that you're expecting and just drop everything there is, But yeah, there are a few ways to achieve that. I'm sure there's even better methods than that. You could just use the actual security context or security permissions of the folder.
Well, this is the thing where we talk about the realities don't always match the pretty picture. We talk about the importance of source control and Git and making sure there's no artisanal changes being made to a server. But things like settings at the IIS level or the web.config, like you could maybe find a way to get those into a source control, but I think a lot of times those are probably too hard. No, I don't know, too hard. Maybe I'm just talking outside of my experience level here, but can you get things like web config to be in source control, or is that just outside the boundary of what really makes sense?
Well, you could use a web.config to do source control, but it also comes back to, that can introduce a different security issue. Web.config can store data source details, maybe not Cold Fusion,
Gotcha.
So then you have a password setting in your source control, so you traded one thing for the other potentially. So I agree. I think that brings up an excellent point is, you may follow the best practices of source control, but something could be changed at the server layer that really isn't source controlled, or you had no knowledge of, or it's, maybe even a misconfiguration from your developer or hosting provider. That can create holes that, you really can't anticipate, or, it's interesting. So, it really comes back down to like a zero trust model, right? Is only deploying what you have full control over, and, exposing things you anticipate. But there's always...
go ahead. Sorry.
No, that was it.
So one of the other things, if we're continuing to talk about a VPS versus containerization model, I feel like a lot of the stuff in containerization is nice, but not critical. Like, it's ergonomics more than anything else, and to each their own. The one thing that I really, really like about containerization that I feel I don't have a good answer for in the VPS world is environmental variables that I love in a Kubernetes context. Somehow environmental variables just magically get exposed to my container. And if I'm going to designate a database source name, I can just say, environment.username, environment.password, environment.database name, that kind of stuff. What is the prototypical approach to that kind of information in a VPS world?
Yeah, so normally in a VPS scenario, that's probably handled more at the application layer, not so much the server layer. So you're setting it with, within the Cold Fusion variables. I guess IIS in theory does have access, and IIS as in a Windows context does have access to certain environmental variables. So you could set those. But I think you make an excellent point. The ability to expose environment variables to your context, even from my experience, is much easier to achieve in Kubernetes. So there are ways to do it. I don't know that it's
I have the pattern that I use on my VPS, which again, we're just trying to get work done, right? It's not the best solutions all the time. I have in my source control something like a config.json.template. And that basically says, okay, the server is going to accept some sort of JSON structure that looks like this, but it doesn't actually have any of the keys in it. Mm-hmm. And then right next to it on the file system, I have a config.json, which is being put in my git ignore. So I know that this file is dangerous. It has private information. It will never be committed to source control. But what that means is that if I ever have to add information to it, I then have to remote into my server and I handcraft that file, essentially take that config.json.template, copy paste it, remove the .template on the end, and then I have to go in and fill those values in a non-web accessible folder, just to be clear. No one should start hacking me. But then getting that config.json into my application server is like hoops and duct tape and elbow grease. And it's super frustrating. I wish, and this is maybe more criticism of Cold Fusion, I just wish that there was a easier way to say, like a .env file that we have in the node world and lots of other worlds, I'm sure. Like anytime this file changes, make it available somehow. And I don't know. I don't know what the answer is. Like that's not the kind of stuff I think about. I just wish Cold Fusion made that easier.
Yeah, we have Charvy coming a few weeks from now.
Charvy. She's going to get the 3rd degree. What's the deal, Charvy?
Remember to re-listen to all of our podcasts for the word Charvy. I'm like, all right, anytime we've mentioned that, I'd have to go list all those questions so we can pepper her.
I'm surprised. Sorry, this is like a total tangent, but I'm surprised at how many times I think to myself, can this be done on a Windows IIS server? And then I'll Google for it. And like 5 out of 10 times, it's like, oh yeah, you can totally do that. All you have to do is change this value in the Windows registry settings. I'm like, no, I'm not doing that. That's not the right answer.
That's super safe. I mean, what could happen by that's in the Windows registry? That's
area to be in for sure. So one wrong decision there, and you don't have a server anymore. So
yeah, that's not fun.
I reloaded Windows on my home PC when I was 17 so many times, messing with stuff like that. I'd do something, and all of a sudden Windows would stop working. I'm like, all right, so probably can't do that. I don't even know where I found stuff. I mean, back in those days. Some AOL chat room, I'm sure someone's like, oh yeah, try this. Or
that's how they get you.
I think Windows, knock on wood, their later versions, like the blue screen of death and these black screens that can occur that completely crash the server, they do seem to be more and more infrequent.
Nice.
So I think they're trying to cater more to a server type solution. But I would love for them to come out with some kind of Windows containerized, lightweight server deployment. There is such a thing as Windows containerization, but it is just not at the level of, what we've been able to achieve. I say what the community's been able to achieve with just, Kubernetes and orchestration in general when it comes to managing containers. But I don't know if you've heard, but Windows, a few years ago, they actually allow you to deploy a Linux distro on their servers now. So you can actually load up Ubuntu in the live Windows system and interact with it in a separate environment. But you could totally tell it's like Windows virtualization in the background. Whenever you go to print the file system, you can see references to the C drive, and you're like, okay, well, this isn't really a Linux file system, but it's interesting to see the advancements that they're trying to make.
But now Windows, kind of along those lines, Windows does have a containerization model these days. Is that part of like the Windows subsystem for Linux? I don't know what I'm talking about. You don't even have to answer this.
Well, they're like .NET, you're able to containerize a lot of the components of that, like the full .NET framework. You can get access to, all the, well, I say all the, not all of the, but, a lot of the, the assemblies that are exposed in .NET and APIs that are native to Windows. They have containers for that now.
Gotcha.
But I've never actually played with them, so I don't know the full capability. I haven't heard great things. I'll say that much, but
fair enough.
And references on the community, I'm like, oh wow, I wonder what they're doing there. And then of course now they've got Microsoft SQL Server you can deploy on Linux, so you don't have to run that on Windows anymore. So I thought that was interesting as well. So, yeah.
What's the most popular database server in your particular world? Because I talk to people who are like, oh, I've been using MySQL for 25 years. Why would I change? And then I talk to people who are Postgres. Why would anyone use anything other than Postgres? In the Windows world, is there a non-SQL server clear winner, or is it just personal preference?
So Microsoft SQL is definitely the leader in a Windows context, I would say. And then MySQL would be second. Postgres, we do see from time to time MariaDB, like the NoSQL implementations, less so. I think if they're using that, they're probably not using a VPS, or they're in AWS or Azure at that point. So
now, sorry, we're like way off topic at this point, but now I'm just curious here. Microsoft SQL Server in a xByte managed cloud hosting context, is that just part of the package, or is that an add-on? Meaning, like, could I install MySQL for free, or I could pay X dollars for some sort of enterprise SQL Server license?
Yeah, that's a great question. So MySQL, you can do the MySQL community, so that's free. And there's an addition called MS SQL Express, which allows, I think, a database up to 10 gigabytes. I can't recall the full limitations. That is free. And then there's licensed additions.
Gotcha.
Yeah.
And does that work the same way as like the Cold Fusion Enterprise license, where it's not as expensive as if I had a bare metal server and I went to install SQL Server? Like, do you guys amortize that cost over however many thousands of customers?
Yeah.
Noise. Toy.
So on our website, if you go check out on the add-on section under products, you will see SQL Server, and we list out the differences.
Gotcha.
So you can see Express Edition there. It is limited to 4 cores and 10 gig database size. Those are probably the 2 biggest limitations.
I'm sure I've said this before on other podcasts that we've done, but database servers are nothing short of magical to me. The amount of volume that a database server can handle when you look at transactions per second. I mean, I know that computers are not human brains and they're doing, a very limited things very well. But when you look at a database server and you're like, oh yeah, it runs 100,000 transactions per second, you're like, that doesn't even make sense in my head. Like, there's no mental model where that seems possible.
Yeah, I've found it always seems, in most of my experiences, the web server has to be scaled before SQL Server ever does. It seems like it can tolerate just so much more activity. It's interesting.
It's bonkers. Bonkers.
So most people are when they're load balancing SQL, is it more for geo redundancy?
Yeah.
Also, database sizes have, I mean, the machines that manage databases have just gotten bigger and more powerful in a very meaningful way, even in the last, like 10, 15 years, my understanding.
Mm-hmm.
I mean, even when we were on 15 Cold Fusion web application servers, we still had a single database and the CPU was like yawning.
Yeah. Very true.
We need to do something about that. It makes much more inefficient applications that require more resources for those selling resources.
I think it was like the number of connections actually put more strain on the database than the actual number of transactions. And I don't even understand why that's the case. Somehow concurrent connections seem very challenging for a database for reasons. I don't know. It's outside my world. That's at a level I don't understand.
There we go. Well, we are at the 1 hour, 10 minute, 70 minute for those of us who are good at first grade math, 70 minutes mark. Any other questions for Dakota, Ben? We can always bring them back. Anything else that's been on your mind that you want to know about? Click into the cloud hosting.
I guess I just need him to answer, should I feel ashamed that I deploy to a VPS?
Absolutely not.
All right, you heard it here. That's it. I'm sleeping easy tonight then.
Ben saves this question for the end.
The icebreaker. Yep.
He had the Justin Scott question asking him about, okay, Justin, I got to ask you this question. Do people really pay people to break out of prisons? I was like, that is awesome.
Well, everything is a pop culture reference to me. Actually, when the other last week when we were talking to Mark Takata, and I was saying, if you're in the bathroom and you slip and you hit your head on the toilet bowl and you have great Scott, I have this vision for a new feature. That was in my mind probably a misquoted reference to Back to the Future. This is Doc Brown. This is his vision Scott. Of the flux capacitor. And I don't think Mark got it, but that's fine. I try to pull in my pop culture references when I can.
There we go. All right, everybody. For those of us who made it to the 71-minute mark, thank you guys very much. I didn't mention them in the beginning, so I will come back and I'll sponsor xByte Cloud. Thank you very much for handling all of our processing. The marketing team there handles the production on this side of things. So thank you guys very much for that. Ben, any last words for our audience? Dakota, any last words?
Risk appetite.
Thank you for having me on. It's really, really fun. And Ben, thank you. So.
Absolutely. Thank you.
All right, guys. Thank you very much.
Cheers.